radical equation. Now the vocab isn't as important, but you kind of get where this is probably going. So these are equations. Uh-oh, my pen's dying. That include, okay, a radical or a square root. So here's the thing that we kind of have to keep in with. Square root and something squared are opposites. And the reason that's important is whenever we're doing anything with an equation, we're always talking about using opposites to get rid of things. If I have plus, I use minus to get rid of it. If I have multiply, I use divide to get rid of it. Well, now if I have a square root, I'm going to use squared to get rid of it. So here's how this is going to work. Now, sometimes you may not have to do all three steps that we've got down here below, but sometimes you may. So my first job is to isolate or get the radical alone on one side of the equation. Now, it may already be alone. If it is, well, shoot, that's easy. I can skip step one. But if it isn't, we got to do whatever it takes to get that by itself. So then once I have that, okay, we're going to raise each side of the equation to the same power. In our case, it's always going to be 2. We're only going to be doing square roots. We're not going to be doing like a cubed root or a fourth root or anything like that. And then we're going to get an equation from that. And then finally, we're going to solve the equation by using techniques we've been doing since the start of the year to solve equations. It won't change at all on us. So what I'm going to do is I'm going to go through an example with you of each of the 3 different possibilities that may come up for you. A couple of them are really quick. One of them is a little longer, but again, with an example, it's something that won't be too bad to deal with. So at the start here, okay, let's say you've got a radical, okay? Square root of x plus 6 equals 3. Once I have that initial equation down, my first job is to take that square root of x plus 6 and square it, because that's the opposite of doing a square root, is to square it. And even though there's no radical on the other side of the equation, whatever I do to one side, I have to do to both. So while on the left, the squared and the square root cancel each other and just leave me with what's underneath it, whatever that happens to be. Now be careful, 3 squared, not 3 times 2. 3 squared is 9. Yep. And then my only job that's left is to minus the 6 from each side, because again, my whole job here is to figure out what x is. And my answer would be 3. Now, am I going to force you to check all of these? No. Okay? I will not. But you could if you wanted to, because then you could plug the 3 in and go, oh, 3 plus 6 is 9. Square root of 9 is 3. Okay, I did it right. So for this one at the bottom, we're going to tweak a little bit. We're going to get rid of that little 3 that's in there. We don't need to deal with the cubes here. But this one's a little bit different from the first one. This is why I wanted to do this one. Because step 1, up above here, said, isolate the radical on one side of the equation. Get it alone. So if I look at number 1, I notice, hey, yeah, this isn't by itself yet. So my first job, before I do anything else, is to minus 1 from each side. So I get the square root of x minus 5 equals negative 2. Now I'm ready to do what I did up in the first example. I need to get rid of the square root because I want to figure out what x is. So I square both sides. And that'll never change. That's always going to be the same step. The squared and the square root will cancel. And just leave me with what's underneath. And then we're going to be careful on the next part. Because when I get to here, it's critical that I keep this in parentheses, and I'll show you why. If I put negative 2 in parentheses squared, I get positive 4, which is what I should get here. If I forget about the parentheses and I just hit negative 2 squared, okay, we do not want the second one. This one is bad. So whenever you're going to square things, make sure it's in parentheses, because that'll keep you out of that problem. So then I got one step left now that the radical's gone. Yep, I've got to get that minus 5 away from my x. So I do the opposite, and I plus 5 it. And once I do that, I get x equals 9, and I'm done. So now, so you're like, okay, we had one that's just got the radical. We got one where we had to add or subtract something, because we always got to have this part alone first. Okay, what else could you throw at us? You're like, ooh, we get to skip one. Okay, we're not going to do funky rational exponented ones, but I do have another one I want to kind of write in. So we'll call this one number 2 here. You're going to like this one because it goes fast. So I got 3x minus 10 under the radical or the square root. And I got 4x plus 18. You're like, ooh, we got radicals on both sides. Well, what's that do? Well, I don't have to isolate. Yep. We're just going to square both sides like we normally would. And this time, instead of having to worry about squaring something, the squared and the square root are just going to cancel. And it's just the equation that's underneath it. So basically, by squaring both sides, there go the radicals. And now my only complication is going to be, I got to get all my x's to one side and solve this. So I notice I have x's on both sides. Okay? They're not on the same side, so I can't just combine like terms and call it 7x. So let's say I decide, okay, I'm just going to move this over here. Since that's a positive 3x, I'll minus 3x on each side. So I've got a negative 10 left on the left side of my equation. 4 minus 3 is 1, or just x on the right. And I still got that plus 18. Yep, and my last step is going to be, okay, I almost have x by itself, but I'm still plussing 18 to it right now. So if I minus the 18, and I'm done. So depending on how many square roots there are, okay, or where they are, can depend a little bit on how I fight the start of my problem. The last type we can run into is down here in example 3. You're like, okay, radicals by itself here, so I don't have to do that at the start. So I'm going to square each side. So let me write this in here. So I'm going to square this side, I'm going to square this side. This side is easy to work with. They just cancel. I get x plus 10. But the other side's a little more interesting. Over here, yeah, because I look at this, I'm like, uh-oh. So we're going to do a little side work here. Remember, x minus 2 squared means there's 2 of these. And for me to multiply this out, I got to use FOIL, or I got to use the box. So when I get to here, I'm like, okay. I go ahead and I write that down there twice. And again, when we're filling in the box, we're multiplying what's on each of the sides. Yep, so negative 2 times x is negative 2x. Same thing working here. And negative times negative is positive. And once I have the box filled, now I'm just looking for common terms. Yep, no more messing with the exponents once I get the box filled. You're like, man, Hardy, this might take a little while, and it may. Okay, but I can't just square each term, or I can't just pretend it's not there and write x minus 2. It wouldn't work. So once I get that, the next step here says write it in standard form, which means get all your terms on one side so it's equals 0. So I'm going to move my x over. So since it's positive, I'll minus it. It's like having a 1. And since this is a positive 10, I'll subtract that. It'll wipe out all this stuff on the right side and make it 0 like it needs to be. Yep, and then x squared negative 4 minus 1 is negative 5x. And then 4 minus 10 is minus 6. And it takes us back into what we were doing just a couple of sections ago. This is a diamond problem. So once I have that set, I'm going to scooch this up a little bit more. When we go to factor this, so I'll make an arrow so we can keep track of all this. Remember, when we go to factor, we're trying to figure out what two numbers multiply to get the number on the end. And the signs are important. I got to take that along. But adds to get the number in the middle. Right, and I can use my chart for this. Or maybe I can just think about it. I'm like, well, wait a minute. If it multiplies to a negative, I know one number is going to be negative and one's going to be positive. I know that for certain. I know that if they add to negative 5, that the negative number has to be the bigger number. I know that. So now I'm like, okay, multiplies one of each. Well, 6 and 1. 6 and 1 might work. So let's see. Bigger number would be negative. So negative 6 times 1 is negative 6. Okay. If I owe somebody $6 and I pay him 1 back, now I only owe him 5. Okay. And again, once I have my diamond done, I just write parentheses with the variable in that number. And that will get me to the next step. And we will not have many of these, but they will show up occasionally, so I wanted to make sure we saw at least one. And then to get my answers, each set of parentheses gets set equal to 0 and solved. So here, since I'm minusing 6, I'd add the 6 to each side. I get x equals 6. Here, since I'm adding 1 to x, I subtract 1. And I get negative 1. And again, I'm not going to get into all of this business right now. Right now, it's just working on using one of our 3 methods to work on getting towards the answer to your problem. So, this again is the notes. Keep it handy somewhere because it could come in definitely useful. And then what we'll do is I'll help out on a couple of these on the actual homework sheet so you've got yourself a good start to work with. So like, let's say, let me jump down to one's a little bit longer here on the front page. Let's jump down to 4. So I look at this one, and this one sort of looks like example 1. I got a radical, I got a square root on one side, but I don't on the other. So I'm going to square both sides. On the right side, where the squared and the square root is, they are opposites, so they cancel. But over here, I do 10 squared. And again, if you need to go to a calculator on that, if you're not sure, it's not 20. I will guarantee that. Okay, that's 100. So I put the 100 in there. I'm like, all right, let's see. My goal is to get the b term by itself. Okay, I'm going to get the positive 1 out of there by doing its opposite. And I got to do it to both sides. And then right, I'm not minusing 11 from b here, because I always did say b minus 11. I'm multiplying negative 11 times b. So the opposite of multiplying by negative 11 would be to divide. And 99 divided by negative 11 is negative 9, and I'm done. So again, you've got to use, though, if you need to have the reference, that's what the examples are for that we do. Let's see if I can find one more. Do I have any complex one? Oh, I see one that I want to play with. Number 6. Yowzers, what's going on here? Fractions. Lovely. In regular setup, it works like example 2 did, the one that we hand wrote in. I got square roots on both sides. Okay. Well, I'm going to get rid of the square roots by squaring both sides. Wipe that out. Wipe that out. So all that's left is what's underneath. And you're like, that's all great and super hardy, but we have a fraction. That's kind of ugh. But again, just keep reminding yourself it's a game of opposites. Okay, so here I'm dividing this by 7. I'm going to get rid of that fraction before I do anything else. So I'm going to multiply both sides by 7. By doing that, those guys cancel. But over here, those parentheses play an important role. Yep, because that's got to distribute through. And we're multiplying. So 45 times 7 is 315. 7 times negative 2 is negative 14. Now I can start working this like I'd work the others. And I just have one suggestion to make. Personally, since the 315's over here, I'd get all my m's over to the left. Yep. I would absolutely add the 14m over. Could I subtract the 1 and get to the right answer still? I sure could. And now it looks a little more normal, finally, at the end. And I can divide by the 15. And believe I get 21. But that's all I'm doing with these. Okay, if both sides have radicals, square both sides. A lot of times they'll end up canceling. So again, it's not anything that's going to go too bad there. Let's see. Let's see if we got one more here to play with. Yes. All right, number 11. This way we basically hit one of everything. So I look at this and I go, okay, number 11. By itself, all right, so I can square it. I can square it. On this side, the squared and the square root cancel, so nothing new going on here. And then n squared on this side. Whenever you get n squared, okay, we need to make sure that everything gets to the x squared side. And by that I mean, here's the n squared side, or x squared, or whatever variable squared it is. I want to keep moving everything to that side. So I would plus n, and I do the opposite of a positive 90. You're like, but there's nothing to really add or subtract that to. That's okay, we can just tuck it on the end. Okay, this is squared, this isn't, so I can't put them together. But they can be on the same side. And now it's like, oh, I got to go back and do one of those diamond problems. Exactly. So I'm like, okay, I need two numbers that multiply to negative 90, but add to 1. Now there's a couple of things I know here right away. From the multiply to a negative, I know one number's a negative and one's a positive. I also know that when they add up, it's a positive 1. So this has got to be the bigger number. And the two numbers are going to have to be pretty close, like one apart from each other. Okay? So when I go looking for, I was hoping I would have another one of those charts handy over there, but I don't. So what I'm going to end up doing here is I would use my chart, and I'll tell you in advance. I'm going to end up with 10 and negative 9 because they're one apart. And again, the chart could absolutely help you with that, or you could just start playing with numbers in the calculator. So you're like, okay, So if these are my two numbers, I'd have n minus 9, because I just steal the number from here with my variable, and an n plus 10, and I got one step to go. So once I have it factored, take each set of parentheses, set them equal to 0, and solve the mini equations. So to get n alone, I'm going to add the 9. To get the n alone here, I'm going to minus the 10. And I've got my solutions. So some of them do. The ones with n squared, they do get a little bit longer to deal with. Because I got to get everything to the squared side, and then I got to do the little factoring game. But again, let the chart help, let the calculator help, and then just kind of work through it that way. But those are the 3 types that are on this sheet. And we're going to be playing with this some more tomorrow too. But do try to get a couple of them done, just so you can kind of reinforce what you've learned so far. And then we will tackle the rest there and get into finals review on Wednesday.